from math as some basic algebra things. Okay. So when we say limit, when we're saying we're talking about the limit of anything in general in real life, limit something very close to the edge مثل ما يقولون, the very approximation to something near the end of it. فبما معناه when we say we want the limit of a function f of x, إنزين, let's say we have a function f of x which is, let's take something simple as if x squared, إنزين. So if I tell you f of x when x is equal to, for example, 3, okay, احنا بنحط هني 3 squared, we will put 3 instead of x, وبيطلع لنا جواب 9. Very simple. However, let's say if we want to talk about the limit of this function. So when we say limit, this is how we write it. Limit of x as x either tends to 3 or approaches to 3. So this is how we usually write it. X arrow and in 3 of the function f of x. في الحالة limit as x tends to 3 for our function is x squared. Okay. هني بما معناه we want to know the value of this equation or this function when the value of x is getting very close to 3 but not actually equal to 3. يعني when the value is basically something like 2.999999, very close to 3, يعني it's going to reach 3 but it's not exactly equal to 3. ففي هالحالة طبعا we can just substitute this 3 in here. This 3 will be substituted in here and we can solve this equation very easily. It is going to be 3 squared again, which is the same answer, 9. But how is it done usually in limit? In limit, احنا بناخذ values that are very close, like 2.9 بنجرب وبعدين 2.99 or 3.01 وبعدين 3.001, and we will be substituting it in x, and you will realize that the answer is always going to be very close to 9. So if we do the limit of 2.9 to the power, يعني if we substitute for the limit 2.9, زين يعني بيكون 2.9 squared, which is equal to roughly 8.41. It's not exactly equal to 9, but it's going to get closer every time we increase this limit. فإذا سوينا 2.99 a bit more accurate, بيكون الجواب equal to 8.401, and then it will keep getting closer and closer and closer and closer. Now, this doesn't matter at all in the case of this question, because this question is very simple. Limit, when is it usually applied? It's usually applied to a function when you cannot find the solution of the function directly. For example, let's say we have a function f of x, which is equal to x minus 4, or x squared minus 4 over x minus 2, for example. And we want to find the limit of this function. We want to find the limit of this function as it approaches, as x approaches 2. هني لو تلاحظون, if we want to substitute, يعني if we want to just substitute the x, this is our function x squared minus 4 over x minus 2. If we wanted to substitute the 2 directly هني في x, okay, فوق it will work out, يعني بيستوي 2 squared minus 4. زين, بس تحت بيستوي 2 minus 2, which is equal to 0. يعني this part is going to be equal to 0, which is not possible because you cannot, it's undefined to divide the function by 0 or anything by 0. It's undefined. بس أنا شو قلت في البداية? What did I say? The limit is not when the function is exactly equal to 2. It is when x is approaching 2 or tends to 2. يعني when it goes very close to the value of 2 but does not ever reach exactly 2. So we cannot just simply substitute in this case. فهني what we can do, there is the less traditional way of solving this, which is just by taking approximate over x minus 2, and we will take it for when x, for example, is equal to a number very close to 2, like 1.9 مثلا. زين, and then we can substitute 1.9, يعني بيكون 1.9 squared minus 4 over 1.9 minus 2. And then we put that very quickly in the calculator. 1.9 squared minus 4 over 1.9 minus 2 بيطلع لنا الجواب to be equal to 3.9. زين, if we become a bit more accurate أو نبغى ناخذ a few more decimal places نقدر ناخذ مثلا 1.999 إنزين بيطلع الجواب تقريبا حدود ال 4.0 إنزين وإذا رحنا فوق يعني خذينا رقم شوي أكبر but is close like 2.1 or 2.001 إنزين بعد بتشوفون الجواب يساوي تقريبا 4 وبعدين لو رحنا ل 2.1 بتشوفون الجواب is something close to 4.1 فلو تلاحظون it's ranging from 3.9 up to 4.1 so somewhere in between these two numbers the value should be equal to يعني the limit of this function is going to be the answer but this is not a very accurate way لأن الحين احنا we're not sure if the limit is exactly 4.0 or if we put more decimal places it's going to be 4.000 أو في هالحالة هني 4.00035 or something like that بيكون يعني في a little more decimal places. So how do we solve this algebraically? So let's say again we will write the question x as x tends to 2 then of x squared minus 4 divided by x minus 2. Now algebraically we know that this function is in the form of a squared minus b squared. And we know that this is a plus b times a minus b. Pretty sure you've seen this before. This is just the way of representing this function. فif we simplify it or factor it in this way, زين بيطلع لنا ان x squared minus 4 زين هني ال a value مالنا كم it's x وال b value مالنا what's squared is 4 it's 2 squared فبيكون x plus 2 times x minus 2 if we apply this formula over x minus 2. And now you notice that we can cancel this with this value. Because usually in normal math, we cannot cancel these two values. But since we are doing the limit, we know that x is not equal to 2. X is not equal to 2, but x is approaching 2. يعني في limit. It's not exactly equal to 2. We know that the denominator is not going to equal to 0. We can cancel the functions up and down. So this will simplify to the limit of x to 2 of x plus 2. And now we can substitute this into the x وبيطلع لنا الجواب 2 plus 2 which is equal to 4. And as you can see, it is very close to 4 here when we were adding just approximations. وهني we got the more accurate results of the limit of x as it tends to 2. And that's it. This is the whole idea of limit. The whole idea of limit is trying to find out an approximation of a function where you cannot solve the function directly by substituting the value in it. طبعا, as you notice, it is very difficult. I mean, it's not very difficult. It's very simple, but the difficulty will come in finding algebraic relations نفسه. هني تعرفون كيف تسوون factorization وهالما جرى. This is the whole idea of limits. All right. Any questions before I start solving questions? Now I'm going to just go into problem solving and do as many problems as I can عشان we get the idea. So does anyone have any questions about limits in general? These are some functions اللي you guys should يعني be familiar with at this point. اللي هو simple يعني simple ways to simplify functions that are in a specific form. يعني مثلا إذا عندكم a plus b squared تقدرون توزعونه أو تقدرون you instantly just put this as the answer أو إذا عندكم هالform a squared minus b squared نفس اللي سويناه قبل شوي this is the form that you will take أو في حالة الكيوب إذا عندكم مثلا a cubed minus b cubed this is the way to factor this form. You should have a general idea about this. I don't think they will bring this to يعني ما بيبون لكم هاي في الفورمولا sheet. So you guys should know the basic ones, at least the squared ones and the basic cubed ones عشان you understand how to factor and then solve questions of limits. So let's start solving the first question. So here it says the limit as x goes into 2. Evaluate the limit by simplifying the following equations. فبعد بقى بس برد اكتبها limit as x approaches 2 when x squared plus x minus 6 divided by x minus 2 is the function. زين فلو تلاحظون you cannot directly substitute هني لأنه it will become undefined. So we cannot do direct substitution. So we have to simplify. وأسهل طريقة هني you can just factorize the one at the top. فبعد مرة بعيد أسرع طريقة كيف تسوون factorization باستخدام mod 5 3 انزين mod 5 3 you will use it for anything you have a square in it عشان you find it in factor form. فيوم تصور mod 5 3 for the first one ال A يساوي 1 ال B يساوي 1 وال C يساوي minus 6. okay, so 1 1 minus 6, you're gonna get x1 is equal to 2 and x2 is equal to minus 3. فمعناته if we want to write this as a factor بيكون x minus 2, remember we take the opposite sign of the solution, times x هني minus 3 فبناخذ plus 3. And that's how we factor the above part. So now if we rewrite the limit as x tends to 2, it's going to be x minus 2 into x plus 3 divided by x minus 2. Now you know you can cancel the bottom and the top. Again, I have to repeat this. Usually in math, you cannot cancel these two لأن the bottom one, if x is equal to 2, يساوي 0, so you cannot solve it. However, in this case, since we have a limit, because we have a limit, معناته we know it is approaching 2 and that x is not equal to 2. We are already defining that x is not equal to 2, it's only approaching it. So we can cancel directly. فمعناته بناخذ the limit of x as it goes to 2 of x plus 3. زين والجواب بيكون if we substitute now, we can substitute 2 here into the x. So the answer is going to be 2 plus 3, which is simply equal to 5. And this is the limit of the function. تمام? Very simple, very straightforward. You just need to make sure that you know how to do the factoring part and you will be fine. Let's solve another one. Again, same thing here. We are given x squared plus 5x plus 4. Let me just rewrite it. Limit as x goes to minus 4 of x squared plus 5x plus 4 divided by x squared plus 3x minus 4. Okay? Again, what can you do? You could just do the factorizing of both using the calculator. The top one is going to be, if we just put it in the calculator, 1, 5, and 4. بيطلع x plus 1 لأن الجواب x1 is minus 1. والثاني بيطلع x2 is minus 4. بيكون x plus 4. Same thing we will do for the bottom. So 1, 3, minus 4. This is our A, B, and C values. So x1 is equal to 1. So this is x minus 1. Or x2 is equal to minus 4. So this is x plus 4. Opposite signs. Okay? Now we can rewrite this in factorized form. So the limit of x as x goes to minus 4. If you realize, if you substitute minus 4 into this equation directly, you will get a 0 in the denominator, so you'll not be able to solve it. This will be always the case when you're solving limits. That's why you need to do the factorization. فالحين إذا ردينا كتبناه بس x plus 1 times x plus 4 divided by x minus 1 into x plus 4. If you notice, x plus 4 and x plus 4 will cancel. فبيطلع لنا limit of x as x goes to minus 4 or tends to minus 4 of x plus 1 over x minus 1. الحين نقدر نعوض minus 4 حق x's. زين وبيطلع لنا minus 4 plus 1 over minus 4 minus 1. So the limit as x goes to minus 4 of f of x is going to be equal to minus 4 plus 1 is minus 5. Minus 4 minus 1 is, sorry, minus 4 plus 1 is minus 3. Minus 4 minus 1 is minus 5. So this is equal to 3 over 5, and that is your answer. Very easy, very straightforward. You just need to know how to do your factorizing very, properly and very quickly. Again, part C, same exact concept. تفضل حسين.
Yes, hi Faisal. I was asking one thing. Could I solve the limit questions directly in the calculator using solve method?
By solve method قصدك يعني you just put x as minus 4 and solve. It will not work, no. لأن it will give you as undefined in the calculator because you cannot solve this equation if you are not canceling your 4 and 4, because we're doing limits here. In the calculator, you're not doing the limit, you're just doing solving of an equation directly. So when you're solving an equation directly, you will be substituting -4 هني وبيطلع الجواب 0 في الكالكوليتر في الدينومينيتور. So the calculator will find it as undefined. That's the idea.
I mean, if I use, let's say, as the power or the subtracting of 3.999 or let's say 4.001, will it
Yes.
still work or?
That you can. يعني if you instead يعني قصدك if instead of taking the limit to -4 you want to take -3.99999 كذي يعني. Is this what you mean? Yes. Oh yeah. You can definitely do that, but I don't know how accurate this answer will be. يعني obviously it will be accurate enough and then for the question, but I am pretty sure يعني هني في السؤال it states very clearly by simplifying the following functions. So it does not say using table method. It says by simplifying. Because it says this in the question, you have to follow what the question says. But you are absolutely correct. You are absolutely right. صح بتقدر تسوي بهالطريقة. ولكن it depends on the question, and most probably in the exam they're going to say by simplifying. You can use your method to check if you want. تمام?
Okay, thank you.
No problem. انزين. So again, another question, same idea. So the limit as x goes to -1 of 2x squared plus 3x plus 1 over x squared minus 2x minus 3. Again, just use your calculator, mod 5, 2, 3, and 1. You are going to get x1 is -half. I'm just going to write it directly now in its form. So x1 is -half, so this is x plus half. Okay, and x plus 1. Okay, same thing for the bottom, just plug it into the calculator. So 1 minus 2 minus 3, x minus 3 because x1 is 3, and x plus 1. Okay, if you notice here directly, you can cancel x plus 1 and x plus 1 here. بيبقى لكم x plus half and x minus 3. So if I just substitute x minus 1, and then it's going to be -1 plus half over -1 minus 3, which is going to give me -1 plus half is minus 0.5, يعني minus half, divided by -1 minus 3 is -4, and then so this is going to simply just be equal to 1 over 8, I believe. -1. دقيقة, 1 minute. Let me see what I did here. Minus half. -1 plus 0.5, a divided by -4. Yep, 1 over 8. تمام? Again, same concept, same idea. Nothing is changing here. The solution is the same way for all the questions. You just have to understand how to do your factorizing and you're going to be fine. All right? Just 1 second. I want to just double check one thing. x1, x plus half, x plus 1, x plus 1. Okay, there is one thing I did wrong here. هني, if you notice, in the factoring step, the limit idea, everything I did was correct. But if you notice in the factoring, زين, هني we have 2x. Here we have 2x squared, okay? Because we have 2x squared, we cannot keep it in this form. We cannot keep it as x plus half. لأن if we distribute this, you're going to notice that we're not going to get the same answer. يعني إذا سوينا الchecking مالنا, so x times x plus 1 is going to be x squared. Half times x is half x. زين. Plus x times 1, which is just x, plus half times 1, which is half. If you notice here, we got a different answer from the beginning one. This is going to be x squared plus 3 over 2x plus half. Okay. ليش هاي صار؟ احنا لأنه we divided basically the equation by 2. لأن هني we have 2 in the numerator. This is the issue with using mod 5.3 for a way of solving factorization. So instead of using mode 5, like mode 5.3 simplifies it for the bottom one because your A is equal to 1. In this case, A is not equal to 1. Here, your A is equal to 2. So mode 5.3, remember, that's only solving it to find the solution when it's equal to 0. It is not actually doing factorization. I'm using it as a quick method to simplify. In factorization, you need to just be very careful and see if the final solution is going to be the same as the initial solution. So how can you do that? If you want to keep using mode 5.3, remember, when you have A is equal to 2, you have to multiply, in this case, by 2. So you're going to be multiplying this by 2, and you're going to be multiplying this by 2. So this is going to give us 2x plus 1 divided by x minus 3. Again, I repeat, this is in the case when the A value is not equal to 1. In this case, it's equal to 2. So you have to multiply by the value of A to make sure that you are not making a mistake. And how do you know where you multiply this A? You will multiply it to anything you have a fraction with. All right? This عشان الاكسبlanation بس يكون واضح. This is the formula we got. لا x squared plus 3 over 2 x plus half. We want this to be equal to this part, the green part over here, which is 2x squared plus 3x plus 1. And to do that, we have to multiply by 2. All right? So if it's easier for you guys, you can do just the basic way of factorizing, where you look at the A and C values and you look at the B value and you do the plus and minus. I will go over that very quickly later on. But in the case if you want to do the shortcut using the calculator, just make sure that you are not making a mistake when you have an A value. So if you notice here, 2x squared, if we distribute this 2, this will become 2x squared here as well. The 2 will cancel out here, and the 2 will cancel out here when you're multiplying by 2, so they're going to be equal to each other. All right? With the next question, I will do the normal way of factorizing. عشان you guys just know how to do factorizing without the mod 5.3. Did I solve this question? I didn't finish solving it. So again, if I just want to solve it really quickly, x, we will substitute minus 1. So if you notice, it's going to be 2 times minus 1 plus 1 over minus 1 minus 3, which is equal to 2 times minus 1 is minus 2 plus 1 over minus 1 minus 3 is minus 4. So this is minus 1 over minus 4, which is equal to 1 over 4. Okay? Let's look at the next question. Okay, so we have the limit here. As x goes to minus 3 or tends to minus 3 of t squared minus 9 over 2t squared plus 7t plus 3. Let's do the top part. So the top part is in the form of a squared minus b squared, where our a is t and our b is 3, because 3 squared is equal to 9. So this is equal to a plus b times a minus b. In other words, this is equal to, our a is t, so t plus 3 times t minus 3. All right? Just 1 second, 1 second. Sorry about that. So again, we're just using the form a squared minus b squared, and we factorize this. Very easy, very straightforward. Now, let's factorize this without using the calculator, the old way, as you can see. So to factorize this, first, we're going to look at a equal to 2, b is equal to 7, and c is equal to 3. And then, so we're gonna have to do some trial and error here to be able to factorize this. And the way you do this is, first we do AC, which is a times c, so it's 2 times 3, which is equal to 6. And b, which is equal to 7. We're going to be looking at these two values now, okay? 6 and 7. So the AC value, we need to find two numbers when we add them or subtract them. It will give us this value. And the same values, when we multiply, will give us, oh, sorry, it's the opposite way around. When you add them, it will give you the B value. So this, sorry, excuse me. So again, let me repeat this. So we need a value that when we add or subtract, it will give us 7. And if you multiply these same two values, it is going to give us 6. All right? So how can we find these two values? So we have two numbers that we have to multiply to get 6. So we first will look at this, the AC value, the 6. All right? So we look at number 6. What are the factors of 6? What numbers you can multiply to get 6? You have 1 and 6, and then you have 2 and 3. صح? These two numbers, if you multiply them, you will get 6. So we know it's going to be a combination of 1 or 2. Tamam? So now the value is 6. So now we look at our second case, which is our 7, our B equal to 7. So 7, what two numbers we add from these will give us 7? Is it the 1 and 6 or the 2 and 3? Obviously, it's 6 plus 1 will give us 7. If we do 2 plus 3, it is going to give us 5. So this is not the selected value. So we are going to select the number 1 values, which is 1 and 6. All right, because 6 plus 1 is equal to 7. Therefore, now these are our factors. So x equals 6 and x equal 1. These are our factors. All right. But keep in mind, this is not the same as they're not the actual factors where x is equal to 6. It is the opposite sign. So again, so there is no confusion. You will just write it as plus 1, like this directly, and plus 6. Okay? Obviously, we're going to have x over here, and we're going to have x over here. However, we have an a value, which is 2. This 2. All right? This 2, we are going to have to see, again, the same case with the x's. So if you put the 2 over here, or if you have to put the 2 over here, this is where you're going to be looking at your x value. So here, if you notice, it is 2t squared plus 7t plus 3. If we put the 2 over here, and we distribute, it is going to be 2x squared plus 1 into x, it's going to be x, plus 2x times 6 is how much? It is 12x, plus 6 times 1, which is 6. All right? If we simplify this, this is going to be 2x squared plus 13x plus 6. Now, if you notice, we don't have 13x here, or t. We have 7t. So we cannot put it here, the 2. The 2 should go over. One second. Is my factorizing correct here? Just making sure. Six times 1, 7. 3, 6, okay. Two into t squared plus 7t plus 3. 2 AC is 6. B is. Yes, one more thing I forgot to mention here. Because we have the a value as 2, we have this a value as 2, all right? Remember that we're going to have to divide one of these by 2 as well. This got very complicated because I messed up a lot, so I'm going to repeat the whole steps again, just so we have a more clear picture of how we do this. All right, sorry about the confusion. It's just I haven't done factorizing in a very long time. I will repeat again from the beginning. We have the 2t squared plus 7t plus 3. Tamam? Okay. So we want to factorize this because we have a equal to 2. We will use the old method. We have b is equal to 7. All right. And we have c is equal to 3. All right. So we will look at our a times c value. All right. Just 1 second. Again, I'm very sorry. Just 1 second. Sorry about that, guys. Phone's not stopping, yani, my bad. Where was I? Okay, again, repeat the factorizing very quickly. All right. So if we have our A values equal to 2, we will write our A, B, and C value. We will find out our AC value, which is 2 times 3, which is equal to 6 in this case. All right. And we will look at our B value, which is equal to 7. Okay. So the first value is 6. The second value is 7. We need to find the value if we multiply. When we multiply, we need to find two values, sorry. When we multiply, we will get 6. And when we add, we will get 7. All right. So again, when we do this method, we're going to look at 2, and we're going to look at the 6, and we're going to look at its factors. We're going to look at the 6, and we're going to look at its factors. So 6, 1, and 6 can give us 6, and 2 and 3 can give us 6. So this is the first thing we do. So these are the numbers we look at. Then we look at the 7. The 7, we need to find two numbers from these, either this pair or this pair, that when we add will give us 7. So in this case, it is the top pair. So it's 1 and 6. So when we do 1 plus 6, it's going to give us 7. All right. When we do 2 plus 3, it's going to give us 5. So this is not what we're going to look at. We're going to look at the 1 and the 6. Okay. So that is the first step we do. So we know that when we have a 1 and a 6, a 1 and a 6, all right, over here, and they're both positive. We know that much. Okay. Now we have to consider the 2 part over here. So we know that this value over here is going to be equal to 3. All right. So we're going to look at the C value now. So our C value is going to be equal to 3. The C value. It's going to be equal to 3. And we know we have to multiply by 2 somewhere. So because the C value is going to be equal to 3, so we're going to have to multiply the 2. Let's go one by one. So because this is the C value that we need 3, we need to divide this by 2 to get that 3. And since we're dividing by 2 over here, we're going to have to multiply by 2 in the other area. This is how a quick, easy method of how I usually solve factorizing. Okay, because we have an A again is equal to 2, we have to multiply one of the x values by 2, because here we have x's, right? Here we have x and x, or in this case, t and t. T and t. All right. So we're going to look at our C value because we are multiplying A and C to get 6. However, here our C value by itself is 3. So we need to have the value here to be equal to 3. When we multiply 6 and 1, we need it to have a value equal to 3. So we're going to have to divide by 2 on the right side. And because we divided by 2 on the right side, we will multiply that 2 into the 2t over here. This is how I usually look at it. So this is going to be 2t, and that one's going to be t plus 3. All right. There are so many other different ways of also doing factorizing methods. There's a way of distributing everything and trying to factorize it one by one. But this is the method I try to usually use to determine, it's the fastest way for me to understand it. And you can always double check when you're distributing. So when you're distributing here, it's going to be 2t squared plus 3 times 2, that's 6t, plus 1t, plus 1 times 3, which is 3. So this is 2t squared plus 7t plus 3. All right. So as you see, this is equal to exactly the equation we started with. Sorry about the confusion earlier. Now we have our factors, and now we can solve the limit. The limit as t goes to -3 or -3 of, we factorize the top part to be t plus 3t minus 3, t plus 3 into t minus 3. And the bottom part is 2t plus 1, t plus 3. T plus 3 and t plus 3 will cancel. So you'll be left with t minus 3 over 2t plus 1, which is equal to -3 over 2 into -3 plus 1, which is equal to -6 over -6 plus 1, which is -6 over -5. So simply it's 6 over 5. And this is how you would solve this question. Factorizing, I would recommend you guys find another method or any other method that you are comfortable with. You don't necessarily have to follow my method. If you know how to do the shortcut the way I did it here, I would recommend doing the shortcut, knowing how to just whenever you need to multiply by 2. If you find that there are a lot of different methods, make sure you're very proficient in it. يعني لازم تعرفون كيف تحلون بسرعة ال factorizing, because this is where يعني the whole test of limits is going to be. Let's do a few more limits before we start the series. So we have the limit of h as it tends to 0 of 4 plus h squared minus 16 over h. Obviously, we cannot substitute 0 directly. It will be 0. So if we want to factorize the top, well, it's already kind of يعني straightforward. You just have to open up this brackets. So you can either just write it as 4 plus h into 4 plus h, and then just do distribution and solve. Or if you already memorized the equation from earlier up top here, it's in this form, a plus b squared. You could just use a squared plus b squared plus 2ab, whichever you guys are more comfortable with. So if we were just going to distribute it, this is going to be equal to the limit as h tends to 0 of 4 plus h. If we distribute 4 into 4, that's 4 squared, plus 4 into h, that's 4h, plus h into 4, that's 4h, plus h into h, that's h squared, minus 16 all over h. If you notice here, the limit of h as it tends to 0, I'm just going to rearrange. So عندنا h squared plus 4 and 4 is 8h, plus 4 squared, which is 16, minus 16 over h. The 16 and the other 16 are going to be equal to 0. So we are going to be left with the limit as h tends to 0 of h squared plus 8h over h. We can just take h as a common factor up, so it's going to be h into h plus 8 over h. H and h will cancel, so it's going to be the limit as h tends to 0 of h plus 8. So it's going to be equal to 0 plus 8, which is simply 8. And that's it. All right. Again, all I had to do here was just open up, distribute the 4 plus h squared. The constants will go away, and then you can cancel out the h bottom and top, and we're done. Let's take another one. I want to do one where it's not direct. This is just factorization. You know what? Let's do it really quickly. So here it says the limit as x tends to 2 of x squared plus 4x minus 12 divided by x squared minus 2x. Okay. So here it's very simple. And then you will factorize the top one. All right. Again, you can either use mod 5.3 or any method you like, and the bottom one as well. The bottom one is direct. You just take x out as a common factor. You'll be left with x minus 2. The top one is going to be x. We have a plus sign here, so they're both going to be positive. Minus sign here, so it's going to be, actually, they're both going to be negative, positive. No, one is going to be minus, one is going to be plus. And then we have 12 over here. So we need two numbers that you multiply, you get 12, which is 6 and 2. So we know that they're going to be 6 and 2, but because we have a minus sign, one of them has to be negative. That's why we put a minus. 4 is positive, so it's the larger value has to be positive, since this is positive over here. Therefore, it's going to be x minus 2. 2 is the smaller number, and 6 is the larger number. This is another way I usually factorize. So how I did this was, again, if I just want me to explain it real quickly, I look at the sign of the 12, and then minus, if it's minus, that means we're going to have 1 minus and 1 plus, all right? If it's plus, they're both either minus or both either plus. Then I look at the sign of the second value, the b value. In this case, it is positive. Since it is positive, the larger number is going to be this sign, which is positive. So the larger one has to be positive. So 6 in this case will be positive because 6 minus 2 is equal to 4 plus 4. And that's how I determined this factorizing. Again, you could just use the calculator if you like, if that's more comfortable for you. And that's it. Now we can just solve. So x minus 2 will cancel. بيبقى لنا limit as x tends to 2 of x plus 6 over x. So it's going to be 2 plus 6 over 2, which is 8 over 2, which is 4. تمام? Very simple, very straightforward. Let's see if there's any more questions. Again, same idea here, same idea here. Okay, this is the cube one. I wanted to solve this. Now, here, the idea of solving this one is you need to understand the equations I showed you earlier, which is these equations. زين. So the question is the limit of x cubed as it goes to minus 20, x cubed minus 27 over x minus 3, the limit as x tends to 3. So the limit of x as it tends to 3 of x cubed minus 27 over x minus 3. Now this, the top part, this is in the form of a cubed minus b cubed. Then a is x and b is 3. Then the 3 cubed is equal to 27. So it is in this form. A cubed minus b cubed. And then, so it's going to be equal to a minus b into a squared plus b squared plus ab. In other words, الحين بس عوضنا الx for a and 3 for b. It's going to be x minus 3 into x squared plus 3 squared plus x times 3. Then, if we simplify this a bit more, it's going to be equal to x minus 3 times x squared plus 3x plus 9. This is for the top part. The bottom part is already x minus 3. So the limit as x goes to 3 or tends to 3 of x minus 3 times x squared plus 3x plus 9 divided by x minus 3. X minus 3 will cancel. So this is going to be equal to minus 3 squared. No, sorry, it's plus 3. 3 squared plus 3 times 3 plus 9, which is 9 plus 9 plus 9, which is equal to 27. Okay, again here, the trick here is to know that this form of a cubed minus b cubed, how to solve it, and that's it. Let's look at another question. Okay, so there are rules for limits I didn't go over. Again, when it comes to solving, it's going to be the exact same way. But the one thing I want to show you here is just the rules, how you can apply them. limit laws they call them. فعندنا هني limit of x as it goes to minus 7 of 2x plus 5. The limit laws, all it says is نقدر احنا we separate this to write it this way of 2x and then plus the limit as x goes to minus 7 of 5. Obviously, it goes without saying the limit of a constant is the constant itself. So this whole part is just going to be equal to 5. وبعدين هني we just put the minus 7 inside. So this part is just going to be 2 into minus 7 plus 5. فالجواب بيكون minus 14 plus 5, which is equal to minus 9. All right. So this is one of the rules for limits that you can do. Another rule we have for limits is multiplication. So earlier we saw addition, we can separate them. Multiplication, same thing. We can also separate them. So the limit as x goes to 6 of x minus 5 then times limit of x goes to 6, the same exact limit of x minus 7. We could just separate them and solve them separately. We could also solve them directly, but they both work exactly the same thing. But these are just some of the laws you can apply. So it's going to be 6 minus 5 times 6 minus 7. So it's 1 times minus 1, which is just equal to minus 1. Okay. Another rule again for division, it's the same exact thing. You could just separate them. So here you have x minus 5 and x minus 7. The limit of x to 5 of x minus 5 times limit of x to 5 of 1 over x minus 7. And again, it seems unnecessary to do this, but you can if you want to. Here, this is going to be 0. If you put 5 minus 5, it's 0. This is 1 over 5 minus 7. Doesn't matter what the value is. 0 times that is going to be just equal to 0. Okay? There's also a different method here. Here, what you can do is you can just separate the bottom part and the top part, but if you notice, you're just going to get the answer directly anyways, because if you just put, this is the limit of x as it goes to 0 of 3 over square root 3x plus 1 plus 1. If you just put the 0 directly in, you get to solve this equation. So it's 3 over square root of 3 plus 1 plus 1. So it's 3 over square root of 4 plus 1, which is 3 over 2 plus 1, which is equal to 3 over 3, which is just simply 1. Is that right? Yeah, simply just 1. Okay. Oh, this is limit of x goes to 0. I did not substitute the 0. So this is just 0. This is going to be square root of 1. This is going to be 1. 3 over 1 plus 1, which is 3 over 2. Okay. Simple. You just substitute the 0 directly and then you just start solving. There is another one that I wanted to show you with the roots. I think it was this one. Yes. So when you solve something like this, limit of limit as x tends to 1 of x minus 1 over square root of x plus 3 minus 2. Now, if you notice, if you substitute the 1 here directly, it's going to become, you cannot substitute this directly because it's going to become 1 plus 4. Square root of 4 is 2. 2 minus 2 is 0. So we cannot do this directly. The way to do this is if you have the square root, there's something called conjugation. Conjugation, if you remember, if you've done computing fundamentals, you will be taking the complex conjugate. Remember when we used to do complex conjugate? So we will do the exact same thing here for the bottom part. So you see how this is the square root of x plus 3 minus 2. We're going to be multiplying it by the square root of x plus 3 plus 2. Up and down, obviously. Anything you do down, you have to do it up. The reason behind this is now we are just going to get rid of the square root in the bottom. So if I simplify this, it's equal to x minus 1 times square root of x plus 3 plus 2 at the top. At the bottom, if you notice, this is in the form of a minus b times a plus b. صح ولا لا? If this is our a, this is our b. And if you notice, the signs are opposite in the middle. So it's in the form of a minus b into a plus b. And this is simply just equal to a squared plus b squared minus b squared, sorry. Okay? This is from the normal formulas, the normal equations that we can apply. So if we just write it down, so again, our a is square root x plus 3. So square root x plus 3 squared minus square root 2 squared. زين السكوير بيتكنسل وهي السكوير روت وهني minus 2 it will just be simplified. So limit of x as it goes to 1 of x minus 1 into x plus 3x plus 2 over the square root where squared will cancel. You'll be left with x plus 3 minus 2 squared is 4. Now we can substitute the 1 for the x's. So it's going to be 1 minus 1 minus 1 let me make sure everything's right up here. times the whole reason we did the conjugate is to solve this. If we simplify at the bottom, you will notice we have x minus 1 up top, square root of x plus 3 plus 2 over x plus 3 minus 4 is going to become minus 1. So we can cancel the x minus 1 and the x plus 1 up top عشان we get rid of the negative 0 from the bottom. وبيبقى لنا the limit as x goes to 1 of square root x plus 3 plus 2, which is equal to, if we just substitute the 1 now, it's going to be the square root of 1 plus 3 plus 2, which is simply equal to square root of 4 plus 2, which is 2 plus 2, and it's equal to 4. Remember to simplify everything so you can cancel out. That's the whole idea of doing all of this. Let's do another one using the conjugate method. This one, yes, this one. So again, we will do the exact same idea here. So the limit of x as it approaches 9 of square root x minus 3 over x minus 9. And then another way we can simplify this again, we could just multiply up and down by square root x plus 3, opposite sign. Remember that this is minus. This is going to be the opposite sign. Divided by square root of x plus 3. Anything we do up, we have to do down. This is going to give us limit as x goes to 9. A squared, which is x squared x squared, minus b squared, which is 3 squared, okay, for the top part, divided by x minus 9 times square root x plus 3, okay? So this is equal to x, then the square root and the square will cancel, minus 9 divided by x minus 9 into square root of x plus 3. X minus 9 will cancel with x minus 9 at the bottom. You are left with the limit as x tends to 9 of 1 over square root x plus 3. So it's equal to 1 over square root 9 plus 3, which is equal to 1 over 3 plus 3, which is equal to 1 over 6. Tamam? And this is the whole concept of limits. One more example, and then we will move on to what's it called? To the series, the Taylor and MacLaurin series. They're very straightforward, those series. No confusion there. And we have the limit to infinity, which we did not talk about yet. Zain. So when x tends to infinity for a general number, Zain, and infinity means there's either positive or negative infinity. معناتها it's always increasing. It's always approaching the maximum possible number in math. To solve a question like this, it's the exact same idea that we will do. Just two concepts you need to know. So if x is equal to infinity, then for a function f of x, let's say f of x is equal to just simply x. So, or say, let's say x squared. So infinity, if it's squared, if it's in the numerator, it's always going to be infinity. If f of x, if x is in the denominator, so for infinity, 1 over infinity, this is always going to be 0. Why? Because 1 over a very, very, very large number is going to be a very, very, very small number. So when it comes to infinity, it is going to be equal to 0. This is the most important concept you need to know about the limit of x to infinity. So how do we solve this equation? Or this question? It's very simple. So we have 2x squared minus x minus 2 over 4x squared plus 4x plus 1. All right. When it comes to infinity, the limit as x goes to infinity, we want to divide here by x squared, by the largest value we have. So here we have x squared, and here we have x squared. We want to divide up and down both of them by x squared. So if we just look at the top part for now, it's going to become 2x squared divided by x squared minus x divided by x squared minus 2 divided by x squared. Okay, this is for the top part. Now the bottom part, Again, same idea, 4x squared divided by x squared. Again, the reason we're dividing by x squared is because of the x squared over here. And this is because of the x squared, the top part because of the x squared above there. So minus 4x over x squared plus 1 over x squared. Tamam? If we simplify this, if we simplify these two equations, the green one, x squared and x squared will cancel. So it's going to be 2 minus x over x squared is 1 over x minus 2 over x squared. Then all over. Let's simplify the purple part. So it's 4 minus 4 over x plus 1 over x squared. This is the limit as x approaches infinity. Tamam? So remember what I said. The limit as x approaches infinity, if it's in the denominator, if infinity is in the denominator, we get 0. So if we substitute now the limit, if we substitute infinity into the x's of this equation, this is what we are going to get. We are going to get 2 minus 1 over infinity minus 2 over infinity squared divided by 4 minus 4 over infinity plus 1 over infinity squared. احنا قلنا 1 over infinity معناتها 0. So these are all going to become 0. صح ولا لا? Because any number over an extremely large number is going to be equal to 0. So this is going to be equal to 2 over 4, or simply, it's just simply equal to half. So when the limit as x tends to infinity of this function is equal to 1 over 2. Tamam? That's the idea of how to solve with infinity. When you have infinity, you're going to take the largest power, in this case x squared for the numerator, and divide the top side with that. And the same thing you will do with the denominator. All right. And that's it for limits. Any questions about limits? Again, sorry about the confusion with factorization. My recommendation is try to review old techniques for factorization. It is very basic algebra, very old methods. There are so many different methods to do so. It will help you for sure when it comes to the limits, because that's the whole idea. Let's take a 5-minute break. I'm just gonna go grab some water. Yani at 11:15, inshallah, we'll continue. All right. And we will start Taylor series. Taylor series is very straightforward. It's very easy. So is the MacLaurin. Even easier than limits for me, at least. You just have to know how to do your basic differentiation and all of that from before. So inshallah, we will continue in 5 minutes. All right, let us start with the series. Okay, so I will start with Taylor series first, even though they teach, I believe, MacLaurin first. The reason I'm starting with Taylor is because MacLaurin series is basically a type of, it's based on the series of Taylor. The whole idea of Taylor series is it's this equation. It's using this equation to solve questions. So what is the point of Taylor series? So Taylor series, it's for a function. So Taylor series, we use the Taylor series so that if we have a function that is not a polynomial and we convert it into a polynomial form, for example, if we have an exponential function or we have a sine function, sine of x, sorry, or cosine of x, or ln of x, anything that is not a polynomial, we want to convert it if it's exponential. Remember the first class we covered exponential functions, rational functions, irrational, trigonometric functions, all of that. We convert these into a form that they are the form of a polynomial. And this is basically the equation that we are going to use. It's very straightforward and very direct, okay? So if we want to apply this, let me explain what this equation actually means. It's very straightforward. So we have a function f of x, any function f of x. It's going to be f of a. A is the value, the center value, the point that you are trying to find the function of close to. So for example, a value يعني like 3 equal to 3 or 5, it will be given to you in the question in the case of a Taylor series. So you'll find the f of a, so you'll substitute 3 into x and you'll put the value you find over here. This f prime is the first derivative, And then what this means is it's df by dx. You are going to differentiate f by x one time. And then you're going to substitute again the value of a into that derivative. Again, multiplied by x minus a, and again a, you will be, x is going to stay as x, you're not going to move it. It's going to stay as the value of x, the variable x. Minus a again is going to be the value you're going to substitute over 1 factorial. If you remember, factorial is simply if you have 1 factorial, it's just equal to 1. 2 factorial is equal to 2 times 1. 3 factorial is equal to 3 times 2 times 1. Oh, etc. That's how it is. And you can just plug it into the calculator. There's the factorial function there as well. That is what the factorial is. And then you go to f double prime. So this is your second derivative. This is your second derivative. So it's d2f by dx squared. يعني basically you'll be differentiating twice, and then يعني here you will find the derivative of f of x, and then you will do the derivative of the derivative of f of x, and that's basically all it is. And you just apply this equation, put in the values, and you can solve any question. Very straightforward. So let's start with the very first question. So Taylor series, okay, we have f of x is equal to 1 plus x squared. Your first step is always finding the derivative of x, all right? The derivative of x is equal to, in this case, f prime of x is equal to, the derivative of a constant is 0, plus derivative of x is 1, plus the derivative of x squared is 2x. You guys should already know how to differentiate. This should be common knowledge now. So f prime is simply equal to 2x, right? F prime of x is equal to 2x plus 1, all right? And now we find the f of a, f prime of a. First, let's find the f of a actually, then we'll find the f prime of a. So f of a is equal to f of 2 because a is equal to 2. They told us given centered about the value of a, which is 2. So f of 2 is simply we substitute in the main equation 1 plus 2 plus 2 squared. So f of a is going to be 1 plus 2 plus 4, which is 7. Okay, so that's our first value. Now we will find f prime of a, which is equal to again, we will substitute into this equation the value of A. We will substitute it into this equation. So we're going to be finding f prime of 2. So it's going to be 2 into 2, which is A, plus 1, which is equal to f prime of A is equal to 2, that's 4 plus 1. So it's simply equal to 5. Let's differentiate again. So let's go for f double prime of x. It's equal to, so the second derivative, we are going to differentiate this equation. So 2x plus 1, the differentiation of it is just 2, or 2 plus 0, to be more specific. So f double prime is equal to a constant of x. So no matter what the value of x is, f of a is going to also be equal to the same value. And then if we differentiate f again, f triple prime of x, we are just differentiating this, it is going to be equal to 0, and it will always be equal to 0. So we only have we have f, and then we have first derivative and second derivative, and that's it. That's the whole solution. So now we apply this equation. I believe this equation will be given in the exam. I'm 95% sure they're going to give you this equation in the exam. Just double check with your tutor. Now we just substitute the values for f of a. So f of a we calculated earlier. F of a was equal to 7. So f of x is equal to 7 plus f prime of a. What's f prime of a? We found out to be 5. So 5. Let's write it this way. F prime of a. And then f prime of a is equal to 5 times x minus a. What is a? A is equal to 2. So minus 2 divided by 1. 1 factorial is just 1. Plus the second derivative, f double prime, is equal to just 2 of a. F of a, f double prime of a is equal to 2 times, so this is now we're just substituting this. X minus a, again, x stays as x, minus a, what is a? 2 squared over 2 factorial, which is 2 times 1. Plus, we found out that f triple prime is equal to 0, so it's no function, so it's plus 0. And once it's 0, it's always going to be 0 for the remaining as well, because f triple prime, f4 prime, f5 prime, it's all going to be equal to 0. So now we could just simplify this. So f of x is equal to 7 plus 5 into x minus 2 plus 2 and 2 can cancel, x minus 2 squared. And this is your Taylor series for the first question. It's very straightforward, very direct in this case because you're given a simple polynomial, so it is not continuous. This is what they call a convergent series, meaning يعني you reach a limit, يعني ما بيكون عندكم infinite number of f primes, يعني of values. It does not continue on forever. So this is what they call a convergent series. There is the case of a divergent series, which we'll see in the next question now. اللي هو it is continuous and it does not stop. Actually, this is also the same. Let's do e to the power of x. Actually, let's do 1 over x. Okay, let's do 1 over x. It's a bit more complicated. Let's do 1 over x. So again, you will do the exact same thing we did earlier. First thing, you will find your f of a, which is equal to f of minus 1, which is equal to 1 over minus 1. We're substituting for x, which is equal to minus 1. So we found our f of a to be minus 1. Let's do our first derivative. So f prime of x is going to be equal to, remember this, if we rewrite f of x again, it's simply as saying x to the power of minus 1. So the derivative of it is going to be minus 1 times x to the power of minus 1 minus 1, n minus 1. All right? This is just differentiation, how differentiation works. You guys should already know this from Math 1. So this is going to be equal to f prime of x is going to be equal to minus 1 over x squared, because this is equal to x power minus 1, x power minus 2. And minus 2, we can take it down and it will become 2. All right? Now we found this. We can find our f prime of a. In this case, f prime of a is f of minus 1. And we just substitute. So minus 1 over minus 1 squared, which is equal to minus 1 over minus 1 squared is positive. So it is again minus 1. All right. Again, we will do the same thing for f double prime of x. We will differentiate the one before, which is minus 1 over x squared. Again, this is the same as minus x to the power minus 2. So it is going to be minus 2 times x to the power of minus 2 minus 1. So this is equal to minus 2. So there's a minus here as well, because this is minus 1 times. So minus 2, minus and minus becomes plus, x to the power of minus 3. So if we want to rewrite this, f second derivative, double prime, is 2 over x cubed. We find now at the center point A, which is minus 1, 2 over minus 1 cubed. Minus 1 cubed becomes minus 1. Remember, if this is an odd number, the negative will stay. If it is an even number, the negative will go away. So it's 2 over minus 1. So it's equal to negative 2. Okay? Again, we will do it one more time for the third derivative. Usually they will ask for the first 3 terms of x. So this is simply, we're going to be taking this and we're going to derive or differentiate. So it's going to be minus 3 times 2x minus 3 minus 1. So it's equal to, this is going to be equal to minus 6x minus 4. So f triple prime of x is equal to minus 6 divided by x to the power of 4. If we want to find it at the center point of minus 1, this is going to be minus 6 over minus 1 to the power of 4. Since this is an even number, the negative will become positive. Minus 6 over 1 اللي هو minus 6. And that's enough for now. We can go on forever with the Taylor series. But usually they will ask for the first 4 digits. Where did the equation go? I put this in the wrong sheet. 1 second. Let me just copy paste this. Zane. Okay. So again, we will take this formula and we're just going to apply this formula to the question above. So f of x is going to be equal to f of a is minus 1. So f of a first is equal to minus 1 plus f prime of a. What is f prime of a? It is also minus 1. So plus minus 1, put it in brackets, x minus, what is a? It is minus 1. A was given to be minus 1. So minus 1. Do not confuse yourselves with the signs. Divided by 1 factorial, which is 1. So this is our first derivative. So minus 1. Let me rewrite it just in green so there is no confusion. This is this part. Okay. Minus 1, which we got from f of a, x minus 1 divided by 1 plus. Now the second derivative, this part is the second derivative. Second derivative we found to be minus 2 into x minus a, which is minus 1, squared divided by 2 factorial, which is 2 times 1. And then the third derivative, which is this part over here. Then third derivative, we found it to be minus 6 at the centered point. So minus 6 times x minus a, which is minus 1 cubed divided by 3 times 2 times 1, 3 factorial. And it will keep on going. So this is plus dot, dot, dot. Okay. Now, if we just simplify this equation, f of x is equal to minus 1 plus into minus becomes minus, so minus 1 again, times x minus times minus becomes plus 1 divided by 1, and then plus minus 2 plus into minus becomes, let me put here some parentheses so there's no confusion, minus into plus into minus becomes minus 2 times x plus 1 squared divided by 2 plus into minus becomes minus 6 into x plus 1 cubed divided by 3 times 2, which is 6 plus dot dot dot. Okay, because it is continuously going. We simplify it one last time. We're going to have minus 1 minus 1 and divided by 1 is just 1. So minus x plus 1 minus 2 divided by 2 is 1. So minus x plus 1 squared minus 6 divided by 6 is 1. So minus x plus 1 cubed and so on and so on. It will continue. And this is your solution for it. All right. So this will keep going and going and going. It depends on the question. If they ask you up to how many terms, usually, yani they will say up to the first 4 terms. So this is 1, 2, 3, 4. These are the first 4 terms of the equation. It will depend on the question. And this is basically how you do any Taylor series, no matter what the situation. It's very straightforward. Okay. Let's look for a different one. Let's do this one. Let's do E, and then we'll go to MacLaurin, which is very similar. So E, again, we have f of x at a is equal to pi. Now keep in mind here, there's something very important here. Because we have a is equal to pi, that means we have to put our calculator in radians when we are solving for questions with pi, if we have a cosine or a sine, or trigonometry in general, because they gave us the value in radians, okay, in pi. In this case, you will have to convert your calculator to radians to solve, all right? That is the main trick here. So f of 0 is going to be equal to, sorry, not f of 0, f of a is going to be equal to f of pi. So we're substituting pi for x, so it's cosine of pi. And cosine of pi, remember to change your calculator into radians. Cosine of pi is equal to minus 1, negative 1. And this is your first value, f of a. Now we do our f prime of x, which is the derivative of cosine is minus sine x. That's simple. So f prime of x is of a, sorry, is going to be f prime of pi, which is minus sine pi, which is simply, if I'm not mistaken, I think is 0. Sine pi should be 0. Yes, sine pi is 0. All right. So it's equal to 0. Again, same thing. We will go for the next derivative, f double prime of x is equal to minus the derivative of sine of x is going to be cosine of x. So f prime of pi is minus cosine of pi, which is minus 1, which is equal to 1. Again, we'll do it one more time. F triple prime of x is equal to minus cosine of x becomes minus cosine. So it becomes minus sine, of x. So it will become simply plus sine of x. Okay. So f triple prime of pi is just simply sine of pi, which is equal to 0. And then if you notice, if we take one more derivative, and then if we go take the fourth derivative of x, it is equal to the derivative of sine x, which is cosine x. So we came back to our main function. So if f4 prime of pi is going to be equal to f of pi, the very first one, because it's equal, the functions are the same, because f double prime of x, or 4 prime of x, is equal to f of x. They're the exact same function because trigonometry, they go vice versa. They go opposites every now and then. So this is simply just going to be equal to cosine pi, which is -1. Okay, and then it's going to be repeating forever in this sequence. So now let's plug this in to this equation. Okay, again, similarly, f of x, f of a, we found it to be -1, plus, this is just f of a, the -1 we found from the very beginning, plus f prime of a, am I writing it down? F prime of a, which is, we found to be 0. So it's going to be 0 times x minus a over 1 factorial. A obviously being pi, x minus pi. But as you can see, 0, so it's just going to cancel out later on. F double prime, we found it to be 1. So it's going to be 1 times x minus pi squared over 2. 2 factorial, which is 2 times 1, which is just 2. 1 factorial is just 1. Plus f triple prime, which is 0 again, of x minus pi cubed over 3 factorial, which is 6, 3 times 2, 3 factorial, and one more plus minus 1 of x minus 3, x minus pi to the power of 4. If you notice, it just keeps increasing, and then it's going to be over 4 factorial, which is 24, I believe. We will see in a bit. Now, if we just simplify this, of course, this is plus continuing. So f of x is equal to -1 plus 0, 0. So this is going to all be equal to 0. So it's not going to be written down. Then plus 1, 1 times x minus pi. So it's just x minus pi squared over 2. Plus, again, 0. This whole thing goes to 0. So plus -1 becomes minus x minus pi to the power of 4 over 4 factorial. And it is going to be continuous. All right. Plus, and then it will continue forever. 4 factorial is simply 4 times 3 times 2, which is 24. And that's it. And this is how you will solve this question. You can keep going up to power 5 over 5 factorial over 6. Yani here, this equation, it is continuous. It never stops. So you can always keep adding to it more values. Yani if I wanted to, I can go all the way to 10 factorial, but no need to waste time. It all depends on the question. This is going to be f 1, 2, 3, 4 of a into x minus a to the power of 4 over 4 factorial plus f 1, 2, 3, 4, 5 prime of a x minus a into 5 over 5 factorial, and so on and so on. This is how it will always continue. So you're just always going to add one extra power and one extra to the factorial, and one more differentiation you will be doing for the question. So that's it for Taylor series. As you can see, it's very straightforward. You just need to know how to do differentiation. This is where the trick is. You need to understand your differentiation. If we go to the MacLaurin series, it is the exact same thing, as the Taylor series with one minor difference. So for the MacLaurin series, if we do part E now, let's just copy paste this equation one more time. The only difference here is, if you notice, the question does not give us an A value, because for the MacLaurin series, the only difference is A will always be equal to 0. So this A is equal to 0, always. So if you notice here, this minus A becomes just 0, it goes away. So this goes away, this goes away, this goes away. There's no, it's just X now. And this A, it's not A, it's just 0 all the time. It's f of 0, f prime of 0, f triple prime of 0. That's it. This is the difference between the MacLaurin and the Taylor. So it's a much simpler version of the Taylor. If we solve just one question now really quickly, f of x is equal to E5x. So f of 0 is simply e to the power of 5 times 0. So e to the power of 0, which is equal to 1. Right? Anything to the power of 0 is 1. we take the first derivative here again. So f prime of x is going to be equal to, so f of x is e to the power 5x. So it's going to be 5 e to the power of 5x. If you remember, this is how you solve the differentiation of e. It is the same thing, but the only difference is you're going to be multiplying by the value of 5 inside here. So now again, f prime of 0 is going to be 5 e to the power of 0. So it's equal to 5 times 1, which is simply 5. Okay. Again, we'll do the same thing for the second derivative of x, which is equal to, again, this is going to be 5 times 5, so it's going to be 25. Or if you want to just be a bit more clear, it's going to be 5 times 5 e to the power of 5x. So it's equal to 25 e to the power of 5x. This is just differentiation. You guys should know this. So f double prime of 0 is going to be 25 e to the power of 0. So it's 25 times 1, which is 25. And you can keep going. I will do one more. So f triple prime of x is equal to 5 times 25 e5 of x. Okay. So this is equal to 125 e to the power of 5x. F triple prime of 0 is simply 125 e0, which is 125 times 1, which is 125. We substitute all of this now back into the same equation. So if we just bring this equation down here, okay. Again, if you notice, the difference here is we just have 0 instead of a. That's the only difference. So again, f of x is equal to f of 0. F of 0, we found it to be 1. So this is 1 plus f prime of 0, which is 5 times x. There's no a, it's just x over 1 factorial, which is just 1, plus, let me make it a bit more colorful. So it's 5x over 1 plus the second derivative of 0 is 25 into x over 2 factorial, which is 2, plus the third derivative was 125 x cubed over 3 factorial, which is 3 times 2, which is just 6. Okay, this is x squared, my bad. Remember, the squared is still here. So x squared, x cubed, plus it will keep going on forever. Okay, and that is your MacLaurin series. So it's 1 plus 5x plus 25 over 2. You could just write it as 25 over 2 x squared plus 125 over 6 x cubed plus, and it will keep going on forever. All right, very straightforward, nothing confusing. The only difference between MacLaurin and series and Taylor series is a is equal to 0 for the MacLaurin series. That's it, and we are done with today's session. If you guys have any questions, you can ask now. But as you can see, it is very straightforward. It's mostly testing your skills in differentiation in the cases of the series. And when it comes to limit, it's all about understanding how to factor, how to simplify the equation. That's what is so important. So any questions? Do you have any like specific question from the MacLaurin series or Taylor series you want me to solve? Or from the limits you want me to solve? I have time for one more question, but I'm pretty sure the concept is very clear. So if you guys have a specific question you want me to solve, you can let me know now.